Working with time domain transient data is more difficult than with stationary frequency domain data or even varying RPM data. Triggers are often necessary to slice the time data into segments that can be processed, overlaid, or even averaged. If the data were not captured with triggers, this can be a tedious, time consuming project. ArtemiS Suite provides automation product triggering to automate the segmentation of transient data for processing. Let's see what kinds of things can be automated. The first example, consider a series of impulse events. One data file contains all the events that are to be processed, where the processing here might be very simple, such as the time and amplitude of each peak, or even a little more sophisticated, the averaging of all the peaks. In ArtemiS Suite, one can build an automation sequence that does some filtering, some resampling, some start and stop triggering, and then some single value calculations based on what's needed. So let's see this calculate in ArtemiS Suite. There's the project. Here comes the calculation, and it will generate, when it's done, a set of discontinuous peak values for each impulse. The time and amplitude of each pulse has already been uh, exported to the legend. If one wants to, one can then generate and export that information to an Excel compatible table. Once the peaks are segmented, they can be time aligned such that the peaks all occur at the same instant in time. With that being done, one can then average all of that time data, all those peaks, into an average plot, generate what the average of that peak is, as well as the number of pulses that went into that average. A useful tool that we'll use in just a bit is the fact that we do not have to operate on every peak at the same time. The top graph shows all the peaks that were in that file. The bottom graph shows the odd numbers of peaks, 1, 3, 5, etc. And the bottom row shows the even numbered peaks. This is a very useful tool we'll take full advantage of here shortly. In this next slide, consider the fact that one might have a cyclical cycle of events where you have a transient, an initial transient, steady state, followed by an ending transient. And maybe at the beginning, you want the peak dB level and peak loudness. The steady state, you maybe want the average SPL and N10 loudness. And the ending transient, you may again want the peak dB level and peak loudness. A script can be built to automate the analysis of that results. This first highlighted row is the sound pressure level of the initial peak. The next row down is the loudness of the initial peak, showing the peak zone value. The next row down is the steady state sound pressure level with its average SPL. The next row down is the loudness of the steady state portion, showing its N10 loudness. The next row down is the sound pressure level of the ending transient with its peak sound pressure level. And the final row in this graph is the loudness calculation, and again showing the peak loudness of the closing transient. Now consider the fact that one may have multiple cycles of cyclical events. So in this case, we have 3 cycles where you have the initial transient, steady state, closing transient, followed by 2 more cycles of the same events. The same automation script that processed the single cyclical event can be used to process the 3 in a row or any n value of the number of cycles. This plot that came up on the screen is really too compressed to be useful. There's 19 rows of graphs. The top graph shows everything. The next 3 graphs show the sound pressure level of the initial transients. The next 3 graphs down show the loudness calculations of the opening initial 3 events. The next 3 graphs down show the sound pressure level of the steady state conditions. The next three graphs down show the loudness of the three steady state conditions. The next three graphs down show the sound level of the ending transients. And the final three rows then show the loudness calculations of the closing transient. Of course, this is very compressed. If you had more than three cycles, it would be really almost impossible to read in a graphical format. This can be dumped again to a table that's compatible with Excel values. What you need to remember today is that productivity is key. We all have less time than ever to do more than ever with fewer people than ever. ArtemiS Suite, when processing time data transients, is faster and easier now than ever before. Contact info@headacoustics.com for more information. We look forward to helping with your advanced signal processing needs.